solve. So solving quadratics by factoring. The only thing we're adding to what we did the last 2 days is at the beginning, we've got to get the problem equal to 0 before we do anything else. Okay, so get it equal to 0 first, and then in descending order, which we were already doing the descending order part, and then we go through the same rules of factoring after that. So we're adding a step at the beginning, get it equal to 0, and then do everything else we've been doing. So the part 2 and 3 there is the same. And then the last thing that you're going to do is use what's called the zero product property. And what the zero product property says is that if two things are multiplied together and they equal 0, what do we know about at least one of them? That it's got to be 0. We're going to take the worst case scenario that both of them are 0. Because 0 times 0 is still 0, right? So we're going to set every factor equal to 0 and solve them. So the zero product property allows us to set each factor equal to 0 and solve. And then that finishes up our job, okay? So everything that we've been doing the last 2 days, exactly the same thing. Adding a step at the beginning to get it equal to 0. Some of them are already going to be equal to 0. Some you just got to move 1 or 2 things to get it there. And then you're factoring it. Once you get it factored, you're going to set each factor for the problem that has a variable in it. You're going to set it equal to 0 and solve the equations to get our answers out of there. So let's look at some examples. So solve by factoring. First example, x squared plus 2x equals 0. Start with the super easy one. Number one thing was get it equal to 0. Is this one equal to 0? Yes, check, we're done. Next thing is descending order. Is it in descending order? Check, we're done with that. Next thing to do is what? GCF. Check and see. GCF on that. So this would have a GCF, wouldn't it? Because it's x squared and 2x, right? What would the GCF? X, and what's left in the parentheses? Good job. And then we look at what's left in the parentheses and look to see if we can factor that any further. Can we? X plus 2 doesn't even have the x squared on it, so there's nothing else we can do to that one. All we had to do was GCF on that one, and that's nice. How many factors are there in the red line there? There's 3 pieces, but there's only 2 factors. A factor is something that's multiplied together. So x is multiplied times the x plus 2, so there's 2 factors. So we're going to set up 2 equations to solve. Okay, so I'm going to set the first factor equal to 0, x equals 0, and the second factor equal to 0, x plus 2 is equal to 0, and we're going to solve those. Hey, that one's nice. I don't have to do anything. It's done. It's got x by itself. Do the other one. Subtract 2. X is equal to negative 2. Both of those are answers to this quadratic. You get 2 answers to the quadratic. 0 and negative 2. If you plug 0 in for x up here, 0 squared plus 2 times 0 is still 0. If I plug negative 2 in, into the problem, negative 2 squared is 4, plus 2 times negative 2 is negative 4. That adds to be 0 as well. So both of those check in my solution. So they're both solutions to this quadratic. Let's do one's a little tougher. Say we had 25 x squared plus 60x plus 32 equals 0. A little tougher one here. A lot tougher one, actually. Is it equal to 0? Good, we're done with that part. Is it in descending order? Yes, so we don't have to move anything on these first 2, so that's good. Now, next thing we look for is a GCF. So 25 60, and 32. Be nice if there was a number that goes into all three of those. So I'm going to look at the smallest number first, 25. Think what numbers go into 25? 5. Does 5 go into 60? Does 5 go into 32 evenly? No, so that didn't work. What else goes into 25? 25. And 25 doesn't go into either of the other two, does it? So we tried. There is not a GCF out of that. So when you're looking for a GCF, always start with the smallest number and use the factors from it to check. There's not one here. So what method do I use to factor the left-hand side? How many terms are there? 1, 2, 3, right? So that's that X thing that we did. What goes on the top of that X? Whatever 25 times 32 is. Be 800. Big number. And then what goes on the bottom? 60. So we need two numbers that multiply to be 800 and add to be 60. So that's a big gap in between those two. But because it's 800, I'm thinking, okay, I'm gonna think about things that start with that 8 is divisible by. What would be a way to multiply to be 8? 2 times 4, right? So to be 800, we turn that into 40 times 20, right? And 40 times 20 does multiply to be 800, and 40 plus 20 is 60, so that happens to be the right two. We're going 40 and 20. Doesn't matter what side you put the 40 on, what side you put the 20 on. But those are my two numbers. Can I take the shortcut with my factoring here? No, there's something else in front of x squared, so I got to do it the long way by grouping. So I'm going to write 25x squared plus 40x plus x plus 32. Keep in mind, it doesn't matter what order you put those middle pieces in. It doesn't matter. At the end of the result, you're going to get the same thing. It'll just look different in the middle. So I'm going to group the first two together and get the GCF of those two. 5 and what else? X. They both got X's. So that'd be 5x plus 8. Good job. And then I group the last two together and get the GCF of those two. 4 goes into 20. 4 goes into 32. That's a plus 4. Get us a 5x plus 8. And then the factored form is going to be 5x plus 8 and 5x plus 4. Now, what do I do with each one of those? Yeah, set them equal to 0 and solve for x. X is equal to negative 8. Divide by 5. Yeah, we get a fraction, negative 8 over 5. Negative sign there, so. And then the other one going to do the same thing. 4/5. Yeah. 5 is on the bottom. Negative 4 over 5. 2 answers. It's a quadratic. You should get 2 answers, even if that sometimes that answer is the same number twice, but it should be 2 answers to these. Okay. Questions about either of those? All right. Let's go get another one here. Let's try this one. 8n squared minus 24n minus 326 is equal to negative 6. Okay, it's not equal to 0 on this one, so we got to get it equal to 0. So what do we need to do? Move the 6 by addition because it's a negative, so we're going to do the opposite there. So plus 6 to the 326. So 8n squared minus 24n minus 320 equals 0. In descending order. Now, so that means we now start our factoring stuff. So what do we look for first? 8 goes into everybody. 8 goes into itself, 24, and we know 8 goes into 32, so that means 8 goes into 320. So we're going to divide everybody by 8. I'm not going to just factor out the 8 because I'm just factoring a number out. If I were factoring out a letter too, then I would write it on the outside. But because I'm just factoring out an 8, I'm just going to divide everybody by 8. And that'll simplify the problem. That's kind of what we're doing there. So n squared minus 3n minus 40 is equal to 0. I'm going to do the x on that what's left. It'll be negative 40, had to be negative 3. Does that. Multiply to be negative 40, had to be negative 3. Negative 8, positive 5. Can I take my shortcut on my factoring? Yes, because there's nothing in front of n squared anymore. So my factors are going to be n minus 8, n plus 5. And then I'm just setting each one of those equal to 0. And those are the easy solves. It just swaps the sign. Boom. 2 answers to a quadratic. Not bad. Do another. 36x squared minus 42x minus 37 is equal to negative 7. Add 7 again. So this time we're going to add 7 to the like term. So it'll be minus 30 there instead of 37 now. You need something that goes into all 3 of those. Preferably the biggest something that goes into all 3 of those. 6 goes into 36, 6 goes into 42, and 6 goes into 30. Is there anything bigger that goes into any of those? The only things bigger that go into 30 are 10 and 30, right? The 10 doesn't go into either of those, and 30 doesn't go into those. So 6 is the GCF. So I'm going to just since it's just a number, I'm just going to divide everybody by 6. I get a nice little quadratic left over. Trinomial, so I'm going to do X thing. What goes up top? Negative 30. And negative 7 goes on the bottom. What does that? Multiplies to be negative 30, adds to be negative 7. Good job. Can I take my shortcut? Unfortunately not. So I'm just going to rewrite it. I'm going to actually put the plus 3x second. The minus 10x. Because I think that makes my next step easier. Because the GCF of 6x squared and 3x is easier to me. Anyway, what's the GCF of those two? 3x, leaving you 2x plus what? 1. And what we need to pull out of the next two? A negative 5. Good job. Mm-hmm. 3x minus 5 is the other factor. Set each of those factors equal to 0. And solve. All the other ones. Questions about 3 or 4? Nothing too exciting about this. It's same thing. If you got what we've done the last 2 days, it's the same thing again. If you didn't get what we did the last 2 days and didn't feel comfortable with it, it's going to give you a chance to get more practice at it and get better at it. Just takes a little practice sometimes. Let's try this one. X squared plus 5x equals 25 plus 5x. This one here. If I add 5x, it's not going to cancel it out. No matter which. Yeah, because they're adding, I'm going to subtract 5x from both sides. And then that's going to give me x squared. What happens to them on both sides is it cancels out. I get x squared is equal to 25. And the next step is get it equal to 0, right? So what do? We're not doing that yet. Even though that's a valid way of solving that, let's do it by factoring today. Tomorrow will be square roots. We'll do plenty with square roots tomorrow, but let's do factoring. Subtract 25 and get x squared minus 25 is equal to 0. And then we can factor that as a what? Yeah, it's a difference of squares because 25 is 5 squared, right? So that makes the factoring x plus 5, x minus 5. And set each one of those equal to 0. X equals negative 5. So folks that said take the square root, you should get the same answers as if you did the square root. But the factored form there is what we're after today. Solving by square roots. We'll do that tomorrow or Tuesday, whichever one. Or Wednesday. That's ambitious. Maybe. Who knows? What number are we on? 6? Let's try this one. 2x squared equals negative 13x plus 24. Okay, so how do I do that? Okay, so I can move. Which one do I want to move? If I move the 13x, then I got to move the 24 too, right? And that's okay. That works. I could move the 2x squared over there as well. And work it as well. So let's do it the short way, which I think is moving. It's shorter to move one thing than it is to move 2 things, right? So I'm gonna move one thing. And then I'm going to show you how I'd rather it be. Factoring with a negative in the leading coefficient spot is a little bit more difficult than if it were a positive number there, because you got the negative sign involved, so you got to deal with that. So what could I divide everybody by that would get rid of that? -1. And as long as I divide everybody by that, it's legal. So what does that do? It just changes the signs to be positive 2x squared plus 13x minus 24. Instead of negative signs, we got positive signs, more positive signs now. That's legal to do just as long as you change everybody. And just change one, you got to change them all. If you had moved the 13x and the 24, you'd have done the same. If you end up with the exact same trinomial factor. It's no different there. So maybe just a different way of going about it. So we got 2 times negative 24 is negative 48. Got to add to be positive 13 though. That's a little different. Multiply be negative 48, it had to be positive 13. I don't sound like we're not sure. There's crickets chirping around here. So what multiplies by 48? There's something we already know. 6 times 8. Multiplies by 6. 2 times 2, or 2 times 3. And 8 is 4 times 2 and 2 times 6. So we got a bunch of 2's and a 3 involved there. So I'm thinking there's a bunch of 2's. What would happen if I multiplied them all together? 2 times 2 times 2 times 2. That's 2 to the 4th power. What would all of the 2's together get me? 16. So that means that 16 times 3 is 48. How far apart are 16 and 3? 13 apart, right? So I just got to get the signs right. Which one's got to be negative, the 16 or the 3? The 3, because we want it to add to be a positive 13. Again, it goes back, we did a factor tree again. We went back to a repeated prime factor. Anytime we see that, a lot of times with these trinomials, that seems to driving the car around here. So I'm gonna rewrite it 2x squared plus 16x minus 3x minus 24 and group it. First two, 2x, x plus 8 minus 3, x plus 8. Get x plus 8 and 2x minus 3 as our factors. Set those equal to 0. I'll turn it around so it's normal looking now with the 0 on the right. Negative 8. And try again. 3 over 2. And I'm fine with you taking the shortcuts on those. Once you've done enough of these, you're going to get to where you're going to solve them in your head a lot, especially these kind of. No sense in having to show that minus 8. Sometimes this one, it helps to do the 2 steps there, but it's not completely necessary. All right, let's do one more, and then I'll let you do your practice. Maybe you can get it done before we leave today. 14 m squared plus 120 plus 10m is equal to negative 81m minus 20. It's number 7 here. That's a lot of stuff in that one. The toughest one.
That's equal to 0. So you move the two variables on the right side to the left side.
Okay, so got to get it equal to 0. So moving the stuff from the right to the left would be the shortest route to get there. Can we do both of those at the same time? I think that's doable. You guys are in Algebra 2, so adding 81m and adding 20 to their like terms. So be careful about that. They're kind of trying to trick us here and put it in the wrong order. So that's going to be 14m squared plus 91m plus 140. So all in that one step, I moved everything and then rewrote it in descending order. Okay. 81 plus 10, 91, 120 plus 20, 140. I got all that there. So, well, okay, let's see if we can find a GCF. 7 goes into 14, and the 7 going to 140. Yeah, the 7 going to 91. 13 times it does. Hey, 7 happens to be our GCF. Let's divide everybody by 7. Make this a smaller problem. We 2m squared plus 13m plus 20 equals 0. Right? Now I can do the x method on that. So multiply to be 40, add to be 13. Excuse me. 8 times 5. 2m squared plus 8m plus 5m plus 20. Group them up. 2m, m plus 4 plus 5, m plus 4. The factored form, you got the m plus 4 and the 2m plus 5. I do want to see your factored form on these, like when you're doing them. I know we want to jump, since we're solving, a lot of folks want to just jump to the step where you're solving, but I want to see your factored form. So at some point, write me out your factored form there and then solve them. Yes, sir.
So whenever you're doing the factoring, how do you get full? You multiply the 2 into the 4?
Yeah, the number in front times the number on the end. Always we do that. When it's quadratic anyway. So m plus 4 equals 0. We get m equals -4. 2m plus 5 equals 0. -5 over 2. Get those solutions out of that. So solving by factoring, same stuff we've been doing, just giving you a better chance of getting better at it and improving your skill there. Because when we get into higher degree polynomials very soon, you've got to be able to factor smaller ones to even do those. So getting better at it now is